Hello everyone. Now what we're going to do is we're going to spend a little bit of time thinking about blood flow, different heart sounds, and what cardiac output is. So still thinking about the heart. Here are our 4 learning objectives. There's not many learning objectives for this little section. It's only very, very small. Okay, so what you need to understand is that the heart is a pump and its job is to provide the push of blood for all of our cells to be able to access the blood, okay? So our cells need blood. And the heart is the one that pushes the blood around so all of our cells have access to blood at all times. Because cells and tissues will demand blood when they are busy working, okay? So blood flow is driven by tissue demand. So for example, if I just sit down like I am now, just chatting to you, the blood flow to the muscles of my legs will be low. If I all of a sudden go outside and go for a run, then my muscles of my legs are demanding blood. So that is when my heart will kick in and deliver the blood. So blood flow is driven by tissue demand, okay? So what is cardiac output? Cardiac output is a very simple formula and it's calculated by multiplying something called the stroke volume with the heart rate. Okay, now we're going to look at what stroke volume and heart rate are in a minute, but cardiac output is measured in mils per minute, okay, because the stroke volume is giving you the mils and the heart rate is giving you the minutes. Here we go. Stroke volume, what is it? Stroke volume is how much blood is ejected from one ventricle during a heartbeat or contraction, okay? So stroke volume is how much blood comes out of one ventricle every time that ventricle contracts. And what is heart rate? Heart rate is just the number of contractions per minute. Right, so now what we need to think about, now that we know what stroke volume is, we need to think about factors that can influence stroke volume. So there are 3 factors that can affect stroke volume. 3 factors that can make stroke volume go up or down. So the first one is preload. So preload just means how much the heart is stretched before it actually contracts. Now, what you need to realize or understand is that the heart has a unique behavior. What happens is that the more you fill the heart with blood, the more it stretches and then the harder it contracts. And that's called the Frank-Starling principle. And that's just something that the heart does. So preload is just the extent to which the heart is stretched. So if the heart is stretched a lot, it means that there's going to be more blood in there and that's going to increase your stroke volume, isn't it? Okay, let's have a look at contractility. Contractility is the actual strength or how much the cardiac muscle cell contracts. So a muscle cell can contract a little bit or it can contract a lot. Okay, so if your muscle cells are contracting a lot, that's going to increase your stroke volume. If your muscle cells are going to contract just a little bit, your stroke volume is going to be lower or decreased. Afterload is just to do with pressure. So afterload is how much pressure do we need to overcome to push that blood out through the semilunar valves. Okay, so how much pressure do we need to push those semilunar valves open? So if you have low afterload, it's going to increase your stroke volume. If you have high afterload, then you're going to have a decreased stroke volume. So this is just another picture, just reiterating those three factors. So preload has got to do how much of the heart is stretched before it contracts. Contractility is got to do with the strength of the contraction. And afterload is got to do with how much pressure do we need to overcome in order to get those semilunar valves open. All right, so if we go back here, we know that cardiac output is stroke volume multiplied by heart rate. We looked at the three factors that influence stroke volume. So now let's look at the factors that influence heart rate. So what three things turn up or turn down your heart rate? And a lot of this you know already, so it's not really that difficult. First of all, the autonomic nervous system again. Are you sick of it yet? Parasympathetic slows your heart rate. Sympathetic bumps it up. Okay, so the autonomic nervous system influences your heart rate. There are other hormones and ions that also influence your heart rate. Epinephrine, thyroxine increase heart rate. If you have not enough calcium in your blood, that causes a decrease in your heart rate. If you have high levels of sodium in your blood, it increases your heart rate. And if you have high levels of potassium in your blood, what that does, it causes your heart rhythm to become abnormal. So lots of things can affect your heart rate. Others just deals with things like if heart rate is faster in the fetus and it gradually declines with age, so age is a factor. Gender, whether you're standing up, lying down, and then weather, temperature, body temperature. A lot of this is kind of common sense, but just be aware of that these things can influence your heart rate, which can influence your cardiac output. Okay, so cardiac output is equal to stroke volume multiplied by heart rate. There are three things that affect stroke volume and three things that affect heart rate. You can cut out all of this and use it to test yourself. How cool is that?